and the law of sines allows you to find components of a triangle that is not a right triangle. Up until this point, we've only dealt with right triangles. Now we're going to look at non-right triangles and how do you relate the angles and the sides. So in this particular lesson, we're going to develop the law of sines, and then we're going to apply it after this point. But developing the law of sines is not as difficult as what it may seem. And so you're going to have a triangle that's not a right triangle, and you're going to draw in a height. Capital letters indicate the angles. Lowercase letters refer to the sides opposite the angles. So it's always going to be that way. If you have an angle A, the side opposite is lowercase a. And then what you're going to do is basically just fill in two equations with the sign. So the sine of A is equal to H over C. And the sine of C is equal to H over A. That's just looking at the left triangle and looking at the right triangle. And then I want to solve for H on both of them. That's pretty easy. Since they both equal H, we can just set them equal to each other. And at this point, I just want to put that in a cleaner form. So what I want to do is just multiply both sides by 1 over CA, or divide by CA. And when I do that, I'm going to get on the left side, the C's cancel, leaving 1s. So it's sine A over A equals sine C over C. And that's going to be the general pattern of the law of sines. You can write it this way, or you can also write it the other way, where you have the sides on the top and the signs on the bottom. Depending upon what's given in the problem, you'll want to switch this up to make it easier. So now that we developed that idea, it should be easy to apply because you're just looking at these particular equations for the law of sines. Now notice we can write that either way depending upon what's given again. Capital letters are angles, lowercase letters are sides. We can use the law of sines in certain cases, and that's what this is getting at right up front here. You can do it as you're given an angle side, or an angle side angle, or you can also do it using a side angle. That just means what's given in the triangle. You may have seen in geometry the way to prove triangles congruent were with similar notation. And that's just in order working around the triangle of what's given. You'll see what that means when we start getting into some problems. And you also have a case that's SSA. That SSA case is known as the ambiguous case, which means unclear case, which means you may have one answer, you may have no answers, you may have two answers. So you just have to be clear on your math, and your math will show you what the answers are with that. So just note that when you're solving for an angle, you got to be careful with the math. All right, what I want to do is just work with triangles and get missing parts of triangles that are not right triangles. So we're going to do the first problem, and in this textbook, again, just a quick reminder, They use significant figures, so their numbers are going to be slightly different than what you have. I want you just to round to the nearest hundredths at the end. Number 10 in the homework section says if angle A is equal to 33 degrees, angle C is equal to 82 degrees, side B is 18 centimeters, find angle B and then find C, side C. And what you can do is you can basically draw that as a triangle and see what you're looking for in terms of givens and what you have to find. So when I draw something like this, I do not care what that triangle looks like. I'm not trying to fit the correct numbers by scale into the diagram. I just want to get it on paper. So I'm looking at A, B, C, and then just drawing in what I know. B is always opposite. The side is always opposite the letter. And then the question is, what is angle B? And then find side C. So I really want to find out what this is and what that is. Well, the angle is easy. You're given two sides. You're given two angles. What's the third angle of a triangle? I know we're all good at that. So B is equal to 180 minus the sum of 33 plus 82. .65 degrees. So that's the first answer. Then you're always doing like pairing things up in this section because you're dealing with the angle and the opposite side, or the opposite side and the opposite angle. So so you needed that 65 in order to apply the law of sines. Now, this is kind of an important point. I always like to start with what I'm trying to find. If I want to find C, I'm going to write down C over the sine of C equals, and then I want to write down B over the sine of angle B. I put that first because now solving it is going to be a lot easier. So I can now fill in the information. C over the sine 82 equals B over the sine of 65, which is what I've got. And then when I do that, all I have to do is multiply by this bottom on both sides. So it's going to be C equals 18 sine 82 over sine 65. I'm doing this all in one shot when I go on my calculator. So I can pull this up. And I'm going to get 18 times sine 82, and I want to divide by sine 65. And before I do that, I want to make sure in the mode I'm all good with degrees. So I'm good there. Going back and hitting enter, and you're going to see that you're left with C is approximately 19.67. So then you have your two answers and you're done with that. Let's go on to the next problem. The next problem says if angle B is equal to this and angle C is equal to this and side B is equal to that, find your angle A and your side A. Again, what I would do is I would just draw a triangle the same way, just to keep nice and orderly, and then just fill in what you know. When I say 14 degrees and 20 minutes, you have to convert the minutes to degrees. So I want to add 20 divided by 60. Again, remember it's 20 minutes. And when I convert that, it's going to be 1 degree per 60 minutes. And those minutes would end up canceling, and you're left with 1/3 of a degree. Also, C, 75 degrees 40 minutes would be the same thing as 75 plus 2/3, 40 over 60 2/3. B is 2.72. Now, again, what I would do is go ahead and find out what A is. So it would be 180 minus 14 plus 1/3 plus 75 plus 2/3. Those thirds become 1, 15, and 17 is 90. 180 minus 90 is actually 90. We have a right triangle here. So that's my first answer. Then you can do the same thing and apply the law of sines to a 90-degree with a 90-degree triangle as well. So I can, again, I want to find out my A, so I want to write down A over the sine 90 equals, and then you want to look and see what can get paired up. These can get paired up, that's what I want to use. 2.72 over the sine of 14 plus 1/3. Sine of 90 from your trig, you should know is 1. So it's really A is equal to, you do that division and get your answer. One more problem, and that is going to be number 20. A equals 40 degrees, B equals 20, and A equals 18. Find angle B. Now, once you start thinking, okay, I've got this, this isn't so hard, you're going to eventually see that this is the only little quirky thing that can happen when you're dealing with the law of sines. It can create some problems for you. So, again, what I want to do is go ahead and draw this. Again, it doesn't need to match the numbers. So 40 degrees, 20, A is 18. And the question here is, what is your angle B? What is your angle B? And what can happen here is you could have, well, we'll see what happens in the math, but when you see that you have a side, and an angle in that order, you have to be careful. There's kind of a warning that goes out. All right. I want to find B, so I want to write down sine B over 20 equals sine 40 over 18. Multiply by 20 on both sides. Then I want to do the inverse. So it's going to be the sine inverse of whatever that is equal to my B? No, it's equal to my reference angle. And that's where I have to be careful. So I want to go ahead and do that again. All right, 20 times the sine 40 divided by 18 gives me 0.7142. I want to plug that in for the sine inverse. So sine inverse of my answer. Use the answer button. That's the second negative to keep it as exact as possible. Second negative. And then when I hit enter, it's telling me, well, you know what? My reference angle is approximately equal to 45.58. Now, I have to be smarter than the calculator here and say, okay, that can be my B. However, my B can be in two quadrants. Here's one, and here's the other one. That's where the sign is positive. So I really have to consider both of those answers as I go through. So I want to do 180 minus my answer, 134.42 degrees. Now, at this point, you can't just say, all right, I'm done with the problem. Those are my two answers. There's a check involved here. You have to check your answer. And the way that you check your answer is you see, is there enough space for the third angle? If you take 40 degrees and add it to 45, there's enough space for the third angle because they got to equal. They can't go over 180. So there is enough space. If you take 134 and add 40 to it, you get 174, and there's still space because you're going up until 180. But if you were to, so both of those are my answers, and I'm done with the problem. But you have to check and make sure that you're under 180 degrees when you add those two angles up. Now, if you were beyond 180, if you're greater than 180, then you would just cross off that answer and not consider it because there's not enough space. So that's the only little tricky part in this section. Can you F2? And so tomorrow we're going to be doing more with law of sines as well. And eventually we're going to be getting into story problems.